volumetric analysis, right? Now, it is a question from volumetric analysis, and the question reads, calculate the volume of 0.1 mole per dm cube of potassium hydroxide, that is KOH, required to neutralize 12.5 cm cube of 0.1 mole per dm cube of H2SO4, that is sulfuric acid, right? And we asked to calculate for the volume. Like you can see, it's a volumetric analysis question. We asked to calculate for the volume of a base that will neutralize an acid. Now let's quickly write out all our parameters here. We are given the concentration of the acid. The acid here is H2SO4, 0.1 mole per dm cube. And we are also given the volume of the acid to be 12.5 cm cube. Now, the concentration of the base was given to us as also 0.1 mole per dm cube, but the volume of the base was not given to us. Question mark. Now, in order for us to write this, we have to note which formula will be best to solve for volumetric analysis. And we remember our CAVA formula, and the formula goes like this: the concentration of the acid times the volume of the acid divided by the concentration of the base times the volume of the base, equal to the ratios of the acid to the base, and this is NB. Now, in our question here, we are not given a number of acid and a number of base, so we can use a balanced equation to calculate for that. So let's quickly do that. The equation says that the base reacts with acid H2SO4. Now, when base reacts with acid, we know the first substance produced is water, H2O. And we know a salt is formed. And we know a salt is formed when the hydrogen of an acid is replaced by a metal. So when this hydrogen is replaced by this metal, we produce K2SO4. Now, the equation looks unbalanced because the potassium here is 2 and the potassium here is 1. In order to balance the equation, place 2 potassium here, right? Now, the potassium is now 2 here. On the product side is 2. Oxygen is 2 here. Plus this 4, 6. Oxygen is 4. And we have to place 2 oxygen there. Right? Oxygen here is now 2 plus 4, that's 6. 2 plus 4, 6. Hydrogen is now 2, 2, 4. And then 4 hydrogen. So the equation is balanced. So we have now noticed that our number of acid, the number of acid used here is 1. And the number of base, which is the potassium hydroxide, is 2. Okay. So our Ca, concentration of the base 0.1, and Cb also 0.1 for the base, and the volume of acid, which is this 12.5, given to us in the equation, and we are asked to find the volume of the base. The number of the base in the balanced equation is 2, and the number of acid in the balanced equation is 1. Now, since we are asked to calculate for volume of base, let's make the volume of the base, the Vb, the subject of the formula, and if we do that, our Vb will be equal to, cross multiply this will give us Ca times Va times Nb, all divided by volume, concentration of the base times number of acid. Now let's plug in our parameters. Ca is 0.1, our volume of acid 12.5 times our number of base, which is what, 2, divided by our concentration 0.1 times number of acid, which is 1. I can simply do that here. 0.1 times 12.5 times 2 gives us 2.5 all over 0.1, and our final answer will be 25 cm cube of the volume of base. So what this is simply saying is that we will need 25 cm cube of our base in order to neutralize 12.5 cm cube of the acid. If you enjoy watching this video, make sure you share to your friends, and bye for now.